past pointer. So after first iteration, blue will travel to two boxes, 1 and 2. So blue will be here, okay, and the green will be traveling only one index. Okay, we have green here, which will be traveling only one index. Hello all, welcome back to Uncommon Geeks. Myself Vasant. I hope you all doing well. As you know, this is a video series where we're discussing about mainly data structures in JavaScript, and past couple of videos we have discussing about linked list. As you know, in last video itself we have completed the linked list basic operations, and if you not watched my previous videos, I would highly advise please watch them because all the basic operations are completed in those videos. And this video I'll be discussing about some of the most common interview questions. Okay, so what is the question that I'll be discussing in this video is very common interview questions. Okay, and it is will create a good thought process for you to how to approach on linked list. Okay, the question is finding how do you find the middle element in the linked list. Okay, so that is the question. I'll teach you two approaches, one a normal approach and one a advanced approach in this video. So please do watch the video till the end so that you get the complete insight about the how to find the middle element in the linked list. Along with that, you'll also learn a lot of tricks related to linked list. Okay, so watch the video till the end and let's get started. So here if you see, so I'm just continuing from my previous example itself, the entire code remains the same. Okay, so here you need to find the middle element. Okay, so like I mentioned, you already see a lot of code. If in case if you're not seen my previous videos, it will be quite tough for you to get along. So please watch the other videos. I'll link that on the screen, also in the description section. Now here what you need to do, find middle element. Correct, find middle element is a function. Let us start by this. So how do you find the middle element? Correct. So in case if you remember, I am using a variable called size. Correct. I'm using a variable called size. Every time whenever you add an element, I'm increasing the size. And every time whenever we are deleting an element, I'm reducing the size. Okay, remove an element, I'm reducing the size. So many might have thought why Vasant is doing this. Now something might be flashing in your mind. So at least for those who are very, very amateur about the linked list, so finding the middle element means what? So you will get the length of the whatever the data structure, you divide it by 2 and you get the middle element. Correct. So it's very easy. So you can do array.length divided by 2, you will get the middle element, and that you can return. Correct. But linked list has no predefined length. Correct. So if you see in this image which I just created for this video, so every time whenever you want a node, OS will give you a node. Correct. So there is no length that is predefined. Correct, unlike the array. So what is the problem? You don't know the length of the linked list unless you maintain it in an external variable. So I'm maintaining a variable called this dot size, which will maintain the size of the array. So what is the disadvantage of this? You are allocating a variable, and it is, let's say you are having a 1 million node in the array. So one variable is holding the million value. Correct, not a million value, a number million. Correct, which definitely takes some space. So without that also, so a lot of processing is possible. But I would advise you can use this approach because finally you are using only one variable. Okay, I'm going to use an advanced technique also, but this technique is also good where you can maintain a size. Now you know the size, how many elements you have inserted. Whenever you are removing, you are decreasing the count. So now here there are, let's say, 5 nodes. So 5 nodes you have inserted. 5 divided by 2, what is it is 2.5. Correct. So 2.5 node doesn't exist, so you have to seal it means going to the next number. So 2.5 to the seal is 3. So you will be able to find this is the element. Correct. Whenever there are odd numbers, the middle number is the middle, that is 1 2 3 4 5. So 3 is a middle node. But whenever there are even number of nodes, how do you determine the middle element? Correct. So 1 2 3 4, which is middle? 4 by 2 is 2. Okay, but with respect to something like this middle, this doesn't exist. So 4, since the length of this is 4, 4 by 2 will be 2. So it will be this node. Correct, it will be this node. So you can ask interviewer, for even number of nodes, does it wants the second or the third as the middle element whenever there are 4 elements. Correct. So but technically this will be the middle element in such cases. Okay, where the lower one. Okay, so this is how we can find the middle element. Let us code this. Please stay tuned. I'll be teaching advanced technique also in a while. See, if you are liking the content that I'm making on YouTube and you are watching the series from the beginning, I would highly request please like this video on YouTube and do not forget to share the videos with your friends and add a comment. So if you're liking the video, please add a comment. If you're not liking the video, what I can improve is please add a comment. By more and more likes that I get for a video, YouTube will give more impressions to my video. Impressions as in it will show it to a lot of people. When a lot of people see it, they get benefited. They will watch the video. Definitely my channel will grow, but purpose is I'll be able to reach a lot of people by the good content. So please don't continue watching before without liking the video. I just request. Okay, without wasting further time, now let's again continue. Okay, now you got the crux, I think, correct? So what we will do, same first thing though will remain same. If head is null, then there is no way we can calculate the middle element, correct? So if head is null and if this condition is not required, if head is null, then we just return the -1, which is straightforward, correct? So because there is no middle element. If not, then let middle index is equals to size divided by 2, correct? So not size divided by 2, you also need to do math.seal. I guess most of you are aware of this function. Math.seal will just seal the number. For example, if you are 2.5, it will make it 3. 2.8, it will make it 3. 2.1, it will make it 3. Math.floor does the reverse. 2.9, it will make it to 2. 2.2, it will make it to 2. Math.floor and seal does a similar operation. Now here, so you got the middle index, correct? So now what you have to do, index you got, but it is not like array, correct? Where linked list of middle index you cannot return. You have to traverse till that index, correct? So what I'm doing, I'm creating a for loop. Why for loop person? You could have used the while loop. Many use the while loop also, but technically I know the index till which I need to run, correct? Then is the right use case of for. When I don't know how far I need to traverse, then we can use the while. It's something dynamic, correct? So for is the right use case according to me here. So now I'm running the for loop till the middle index. I'll explain with this with the pictorially also, don't worry. Then what I'll do, same thing, middle index. So you know one other thing that we need to let current is equal to this dot head, correct? Then current is equals to current dot next. Finally, whenever you have reached this middle index, for example, in 5 nodes, so you started the iteration with 0, 0, 1, and 2. If I go to the image, so 0, 1, and 2, correct? So if we had size was 5, so 5 by 2, correct? So 5 by 2 is equal to 2.5, and we are sealing it will becomes 3, correct? So 3, so we are running the for loop from 0 to 3. So 0, 1, and 2, whenever it goes here, it will fail, correct? So we are here and it will come out of the for loop. Then what you will do, you will just return the current dot element. You are done. That's it. Let's try to see in case if I miss something. Okay, print a list log ll dot find middle element. Okay, I'm running. So it came 40. Maybe if I floor, what I'll get? Let's see. If I floor, I'm getting 30. If I seal, I'm getting, so why? Because we have 5. So 5 divided by 2 is 2.5. 2.52 we are making it a 3. So 0, 1, 2, 3. So middle index is what? So this 5 by 2 is 2.5 and middle index is 3 now. So 0, 1, 2, 3 times it is going. So 0, 1, 2. But current dot next has also executed. Okay. So problem, if you see here, what was happening? So we are trying to do math dot floor, correct? Math dot seal. Math dot seal means moving the number to the next number. So in this case 0, 1, 2, 3, 4, 5, correct? So in this case what is happening? So we are getting the 5 by 2 as 2.5 and we are making it to 3. So this is running fine. But what is happening? By the time it fails, current, even in that scenario also, current is pointing to its next node. So due to which this is kind of going to one level up. So I'm just making the math dot floor. So in that case, even if it goes to the next index, I'll not have a problem. But now we need to test with even index also, correct? So it is coming as 30 now instead of the 20. Okay. So now whether 20 is correct or 30 is correct, it is something that the interviewer should answer you. Okay. So ask the interviewer, in case of even number of elements, what is the expectation, which is the middle element. Okay. Ask the interviewer and code accordingly. So this was one of the, no, it's not so preferred approach on the internet because nobody uses the size. The preferred approach on the internet, or what many will be doing, is a called two pointer approach. So what is two pointer approach is, there will be two pointers. One pointer will be traveling 2 points at a time. Another pointer will be pointing to 1 point at a time. Okay, don't get confused. Let us start with here. So they will be having two pointers. So both the pointers initially point here. Okay, both the pointers initially point here. Now what will happen is, this low pointer will be pointing every iteration one index. Okay, so let us use two crayons. Okay, so green for slow, and which color let us take? Let us take some blue. Okay, the blue for the fast pointer. Okay, so blue I'm taking for the fast pointer. So after first iteration, do blue will travel to two boxes, 1 and 2. So blue will be here. Okay, and the green will be traveling only one index. Okay, we have green here which will be traveling only one index. Now in the second iteration again, so blue, okay, so this blue will be traveling, so this blue will be traveling, mm, so this blue will be traveling two indexes, so it is here, correct? This blue has traveled here, whereas our green will travel to again one index, correct? So which is here. So now hope you're getting a sense where whatever, when the blue index reaches the end, the green index, or the whenever the fast pointer has reached the end, the slow pointer will be pointing to the middle element, correct? Let us try to mimic that in below as well. Okay, so both here, okay, pointing here in the beginning. Next, uh, this will be pointing to the two elements after, correct? Which is here in the first go. And this will be pointing here, only one index it has moved, correct? And after that there is no index to go to the two pointers, correct? Somewhere it will go beyond or next of next, correct? Whereas this on the other hand will come here to the third index, correct? Will come on the third index. So this is considered to be middle. Got the point, right? So just a simple two pointer approach. So this considered to be slightly efficient than the iterative approach. We did not do iterative approach. Iterative approach is just like nothing but you go through each of the block, calculate how many elements are there, correct? Then you get the length, divide that by 2, iterate the array again or linked list again, and go to the middle element. That we did not do because we are brilliant. We have used the size concept. If not use the size concept, you have to travel it linearly. So that, consider that as a homework for you. Try to implement the linear approach where you can find the middle element. Traverse once, get the length, divide that by 2, then traverse that to the again to the that length. So now let us decode the two pointer approach. Okay, so find middle element, two pointer approach. Okay, two pointer approach. Don't get confused. I'll explain once again if you anyone of you getting confused. Okay, so this remains same, and then I have two pointers. One is let slow pointer. Okay, same like the explanation. It will point to the head itself. Then we have fast pointer. Okay, which is equals to again this dot head. Now we have slow pointer and fast pointer. You know what needs to be done. So you need to run till the fast pointer is not null. You will be learning, correct? Fast pointer not equal to null, or and actually fast pointer dot next should also be not null, correct? Where you shouldn't go beyond the list length, correct? What happened in the even case scenario, correct? Now here what we are doing here is again fast pointer is equals to fast pointer dot next. That's all. You have to travel two times, correct? Slow pointer on the other way is very easy. Slow pointer is equals to slow, slow pointer dot next. Okay, finally what you will return slow pointer dot element, correct? You already know when the fast pointer has exceeded the list or it has reached the last element, the slow pointer is pointing to the middle element, correct? So now find middle element with this approach. Let us see what we'll get. So we got 30, correct? Same as the previous example. If I uncomment this, what I'm getting 30, correct? In this scenario also, let's say I have added 60, correct? So 60 I am adding here. Okay, 60 I am adding here. So you're getting 40, correct? So it's an even number basically, correct? So again I'll do the find middle element. Both the cases I should be getting the same value. Okay, 40 I'm getting. So I'm sticking to this approach of 40. So whenever you have even numbers, you can just ask the information interviewer to get some confirmation and modify it accordingly. But now I think you know all the things. So if you have only the 5, so 30 should be the middle element, correct? So 30 you are getting here as well, and here even 2-pointer approach as well, correct? So that's all about the different techniques. One last time I'll explain you with the objects and I'll end. Okay. In case if you watched already and got the point already, please like the video, share the video with your friends, subscribe, and you can stop watching. For those of you who are still not clear, I'll just explain with the object. So now here you have the object, correct? So what we are doing here is a fast pointer and the slow pointer. So for first, both are pointing to here. Okay. Fast pointer now points here. First it will be, I mean, both will be pointing to this node, okay, the head. Then the fast pointer will be pointing to 1 and 2 here, okay. Fast will be pointing here, slow will be pointing here, okay. Next, fast will go to the next two things, this 1 and 2. So the fast will reach here, okay. In that case, the slow will be coming again here, correct. Slow has traveled from there to here. So now slow is the element. So slowest element I'm returning, which is 30. That's all. Okay. So always keep this object things in your mind and you can start coding. Anywhere you stuck, don't get panic. There is nothing wrong can go here. Correct? Because this is like a coding is nothing but a writing a novel. Correct? So you know what is everything. You know everything what has happened. You have created the characters. Correct? So you know who is doing what, who will be doing what. So you can modify the things. You can see. Let's say I haven't created this one. It may fail. Correct? Where there is a use odd number, it may not fail. Even number, it will fail. Just add the check. Just you should be able to figure out where there could be a problem and just fix it, correct? That's all about this video. I'll catch you next video with another very interesting problem, okay, about single linked list itself. Thank you so much for watching. Please like the video on my YouTube channel. Do not forget to comment if you're liking or not liking or whatever the improvements that you want. If I made some mistake, please add that also in the comment section. I'll try to correct it in the upcoming videos. Do not forget to subscribe to Uncommon Geeks. This entire code is available on my GitHub. You can copy that code and practice on your own. Thank you so much for watching. Catch you in next video.